So in the first section, we looked at how to use Pythagorean theorem to find missing sides of triangles, but in section 8.2, we're going to be using some special right triangles to find those missing distances without always having the pieces we need for Pythagorean theorem to work. And those certain right triangles that have properties to allow us to use shortcuts to determine side lengths without using the Pythagorean theorem are going to be using this one side length. And again, that happens if we have special right triangles. The first of the two special right triangles we're going to use is a 45-45 90-degree triangle. In a 45-45-90 triangle, both legs are going to be the same. They're going to be congruent. Again, if I have 45 and 45, that means it's isosceles, so you'll have two legs that are the same. And that means that the length of the hypotenuse is also going to be rad 2 times the length of the leg. So in the special right triangle ratio, x and x we're going to be using for the lengths of the two legs. And the hypotenuse is always going to be the length of the leg, which is x, times rad 2. So if we're using that to find the hypotenuse of a 45-45-90 triangle, again, here I can't use Pythagorean theorem because we don't know what one of the missing sides are. Instead, we're going to take the leg that we're given. Again, if that is a 45-45-90 triangle, we start with one of the legs. I'm going to take that leg length and multiply times rad 2. So in this case, for x, all I have to do is take 8 times rad 2, and 8 rad 2 is the simplest form of that answer. So I can also work my way backwards. If I start out by knowing the hypotenuse, but I want to use that to figure out the length of one of your legs, and remember they'll be the same because it's a 45-45 isosceles triangle. If I start out with the hypotenuse, I just have to go backwards, and instead of multiplying by rad 2, I'm going to divide by rad 2. And also what we're going to have to do in this section is rationalize. So if I have 5 divided by rad 2, that would be my answer, but I can't have a radical on the denominator of a fraction. So I'm going to rationalize that by multiplying both the top and the bottom of that fraction by rad 2. That's going to allow our rad 2 times rad 2 on the bottom to cancel out and just get 2. And on the top, I still just have a 5 times rad 2, so the numerator is still 5 rad 2. So that full answer for x, again, finding the leg of the side of this right triangle, is 5 rad 2 all over 2. Again, the rule there is that if I want to find the hypotenuse, I want to multiply times rad 2. If I want to find the leg, I'm going to go backwards and divide by rad 2, because the leg should always be smaller than that hypotenuse still. So doing that with a little bit more practice, in this first example, we're given the length of a leg, and we want to find the hypotenuse. So again, whenever we're finding the length of a hypotenuse in a 45-45 triangle, I'm going to take that leg length and multiply times rad 2. So if I take 2 rad 2, multiply by another rad 2, I'm going to have those radicals cancel each other. So rad 2 times rad 2 is just going to be a 2. And since I had that 2 in front, I still have 2 times 2, which gives us 4. So 2 rad 2 multiplied by another rad 2 is going to end up being 4. So next question, same sort of idea. If I'm given the leg length is 9 and I want to find the hypotenuse, remember since the hypotenuse is bigger, I should be multiplying. So 9 times rad 2, I can leave that as my answer because that's as simplified as we can put it. Next question gets a little bit different. So now I want to find the length of the leg, but I have the hypotenuse. And this we have to remember, instead of multiplying times rad 2, if I want to find the leg, I'm going to have to be looking for a smaller length, so that's going to be dividing by rad 2. So if I take 6 and divide that by rad 2, we also have to remember to rationalize it. So multiply top and bottom of your fraction by square root of 2. And again, on the bottom, rad 2 times rad 2 is going to cancel that radical and just end up with 2. 6 rad 2 on the top, I can keep in my numerator and just take one more step there. 6 rad 2, if I'm dividing that by 2 from the bottom, 6 over 2 is just going to make 3. So that final answer for x is just going to be 3 rad 2. Again, we got that by taking the hypotenuse and dividing that by the square root of 2 because we're looking for the leg. So question B is also pretty much the same thing. We want to find the length of the hypotenuse of a 45-45-90 triangle. Or sorry, we're given the length of the hypotenuse. We're given the length is 10. So I have this diagram set up here that's describing that problem, 45-45-90 triangle. We know the hypotenuse is 10, so we want to find the length of one of your two congruent legs. So remember, whenever we're trying to find a leg length, we're going to take that 10 that we have for the hypotenuse and divide that by rad 2. So 10 divided by rad 2, also making sure to rationalize it, should give us 10 rad 2 over 2. And remember, 10 divided by 2 I want to also simplify, and I should end up with 5 square root of 2. So that rule again is to multiply by the square root of 2 if you're looking to find the hypotenuse, and divide by the square root of 2 if you're looking to find a leg. The hypotenuse should always be bigger than the leg. So this time we're putting that in terms of a word problem. we have a high school softball diamond, which is a square. The distance from base to base is 60 feet. So we want to find in the nearest foot how far the catcher throws from home to second. So home to second is listed as D there on your diagram. And again, if I know that each base is 60 feet and it's going to form a square, we know it's going to form a 45, 45, 90 triangle if I cut that diagonal down through the middle, because I'm taking that 90 degrees and splitting it in half into 45 and 45. So if I look at this 45, 45, 90 special right triangle, it looks like 60 is the length of the leg, and what we want to find is the hypotenuse. So we have to remember I'm going to take the leg length and multiply that times the square root of 2. So if it's just 60 rad 2, last thing I have to do is to find that to the nearest foot. So 60 rad 2, if I punch that into the calculator, should get me about 85 feet. So 85 is going to work for that one. So next type of special right triangle, and this is going to be the second of two. So just these two rules we're going to have to remember. 30, 60, 90 is the other special right triangle we could have, and that means that the length of the hypotenuse this time is going to be twice the length of the short leg. So in my diagram here, first of all, we can tell that X is the shorter leg. First of all, because it's shorter, but also because it's opposite of the 30-degree angle. Your smallest angle is going to be opposite smaller sides. And for your longer leg, that's the side opposite the 60 degrees, that's going to be here. So if I know that the length of the shorter leg, in this case it's just X, but if that was any number, to find the hypotenuse, I'm going to take that short leg and multiply that by 2. So 2x is going to be your hypotenuse. And similar, if I want to find the length of the long leg, so the leg I have right here, instead of multiplying that short leg times 2, I'm going to multiply that short leg times rad 3. So hypotenuse, if I already know what x is twice as big as your short leg. And for the longer leg, I'm going to take that short side and again multiply times rad 3. So that means there's several different ways we can figure out our missing lengths depending on the pieces that we have listed. So just depends on what's given. In this first example, we're given the short leg. So we know that 6 is the side that's opposite the 30. That means that's the short leg of the right triangle we're trying to find. And that's actually the easiest starting point to have because that means we're just multiplying to find the hypotenuse and multiplying to find the long leg. So again, using that rule, not using the 45-45 rule, this is 30-60. If I'm given the short leg, if I want to find the hypotenuse, I want to multiply times 2. So if I take 6 times 2, I get 12 for the hypotenuse. And same kind of question, if I want to find the long leg, I'm going to take that short leg, multiply it times rad 3 this time. So that means the long leg of that triangle will be 6 rad 3. So if you start with the long leg instead, so last time we started with a short leg, that made everything a little bit easier. If we start with the long leg, first you want to find the short leg. So a lot of these questions, if you don't start with the short leg, you want to get it as soon as possible. If I know what the long leg is, again, since that was the short leg times rad 3, if I want to go backwards and find the short leg, I have to divide by rad 3. So we're going to do that first. We're going to take 6, divide that by rad 3, and that's going to give us the short leg. And our answer is going to end up being 2 rad 3, but we can see why that happened here. Again, we take the long leg, divide it by rad 3. That's going to tell you what your shorter leg is. But we also have to rationalize that. So times rad 3 over rad 3. I should get 6 rad 3, which that simplifies to our answer 2 rad 3. Now that we have the short leg, though, it becomes like that first question. If I want to then get the hypotenuse, it's still the same rule. If I know what the short leg is, the hypotenuse is just twice as big. So short leg is 2 rad 3. 2 rad 3, if I multiply that times 2, that'll give me the hypotenuse, which is going to be 4 rad 3. So next starting point could be given the hypotenuse. So again, first step is always to find the short leg, because that's going to make everything else easier. If I start with the hypotenuse, I have to remember that the hypotenuse is twice as big as that shorter leg. So if I want to go backwards and find that short leg, I just got to divide by 2. If I know the hypotenuse is 6, for example, dividing that by 2 will give us the short leg, which is 3. And now that I have the short leg, I want to use our same connection, so that same ratio I'm going to use to multiply and get the long leg. So just like in the first question, if I already know what the short leg is, I multiply that times rad 3, that gives me what the long leg is. Same idea here, if I start with the hypotenuse, I want to find that short leg, and then use that same connection, multiply that times rad 3, that should get the long leg. So our only steps here is to take the hypotenuse, divide that in half, that tells you what the short leg is. And now that I know what the short leg is 3, multiply that times rad 3, I get the length of the longer leg. So we do want to get the short leg before we find the long leg. So our strategy is pretty similar, no matter what your given is. If we have the short leg, that's the best starting point because we're just multiplying. if you start with either the long leg or the hypotenuse, the idea is that you want to find the short leg first and then find your last measure second. So let's try that with a few problems here. I guess we're just finding D and F. So starting with D, first we have to identify that D is the short leg of that right triangle because that's opposite of the side that's, opposite the angle that's 30 degrees. So if I'm given the longer leg, in order to get the short leg, we're going to work through this middle group. So we're given the longer leg of that triangle, which means in order to find that short leg, I'm going to have to divide by rad 3. So if I take the 5 that I'm given, divide that by rad 3, only thing we have to do on this is rationalize. So times rad 3 over rad 3, our answer should end up as 5 rad 3 all over 3. And for F, if I want to start with that same given and get the hypotenuse, there's just one more step which is left, and that's to take that short leg that we just found and multiply that times 2. So again, whatever I start with is the long leg. The short leg is going to be smaller than that. I want to find that first because once I have the short leg, I can multiply that by 2. That'll get the hypotenuse. So that previous answer, 5 rad 3 over 3, if I multiply that answer by 2, I get the length of my hypotenuse, which is 10 rad 3 all over 3. So a few other ways we could have this is in a word problem. So it looks like I have an example of a triangular pendant. And the height of the pendant is 18, so I kind of drew our example off to the side here. We know that 18 is going to be this height. We also know that if it's an equilateral triangle that the pendant's shaped in, that's going to tell us what kind of special right triangle we have. If we remember that equilateral triangles always have 60, 60, and 60 for your angles, that means if I look at half of that triangle, that's going to be broken up into a 30, 60, 90 special right triangle. So using our rules, if I want to find the length of the side of the pendant, in this case that would be your hypotenuse, and it looks like the piece that we start with as the given is the longer leg because that 18 would be opposite of the 60-degree angle. So if I work through my steps, the first thing I want to find is the shorter leg, so I'm going to take that longer leg and divide by rad 3. Remember, whenever you want a smaller piece, you want to be dividing. If you want to get a bigger piece, you're going to be multiplying. So in this case, if I start with a bigger piece and want to get the smaller leg, I'm going to divide by that rad 3. First thing you want to do though is rationalize that. So if I have 18 over rad 3, I multiply numerator and denominator by rad 3, and that should eventually simplify to be 6 rad 3. Only thing we have to do after that, since 6 rad 3 would be the length of your short leg, is to get the hypotenuse by multiplying that short leg times 2. So 6 rad 3, if I multiply that times 2, I get 12 rad 3, which is again what we're looking for. To the nearest tenth, I can find that as 20.8. And next question is the same figure, but switching the pieces around. So say instead of the height of that pendant being 18, we're saying if the side length is 18, how would we find the height? So if we reverse that, basically, what is x going to be? And it's still going to be broken up into the same 30, 60, 90 triangle, because I still have that equilateral triangle to start with. So this time, if I know that the side of the triangle is 18, that's starting with the hypotenuse. And remember, you always want to get the short leg first. So if I'm going from the hypotenuse to the shorter leg, I'm going to be dividing by 2, and 18 divided by 2 would be 9 for that short leg. And last thing after, remember, is to go from the short leg to the longer leg. That's going to be a factor of rad 3. So 9 times rad 3 is going to be my answer, which we also want to enter in as a decimal, and I think we get 15.6 the nearest 10. And for that lesson check, I really want to see if you guys can do those independent. We'll come back in class, see how you guys do on that. But use that kind of as a way to gauge if you understand using these ratios. If not, we'll just get some more practice when we look at it together.